Alright, so now I'm going to be discussing inter-process communication. So processes need to communicate with each other in many situations, and IPC is a mechanism that allows processes to communicate. It helps processes synchronize their activities, share information, and also avoid conflicts while accessing those shared resources. So there are mainly two methods of IPC: shared memory and message passing. An OS can implement both methods of communication. So first, I'll start with discussing shared memory. So communication between processes using shared memory requires processes to share some variable, and it completely depends on how the programmer will implement it. Processes can use shared memory for extracting information as a record from another process, as well as for delivering any specific information to other processes. Right. So this is the diagrammatic representation of shared memory. So in the model above, a common memory space is allocated by the kernel. Process A writes data into the shared memory region, that is step one, and then process B can then directly read this data from the same shared memory region. Since both processes access the same memory segment, this method is fast but requires synchronization mechanisms like semaphores to avoid conflicts when multiple processes read or write simultaneously. Then we have message passing, which is a method where processes communicate by sending and receiving messages to exchange data. In this method, one process sends a message and the other process would receive it, allowing them to share information. Message passing can be achieved through different methods like sockets, message queues, or pipes. Right now, in this model, processes exchange information by sending and receiving messages through the kernel. Process A sends a message to the kernel, which is step one. Right, process A sends message to kernel, and then the kernel then delivers the message to process B. That is step two. Here, processes do not share memory directly. Instead, communication happens via system calls like send, receive, or similar. This method is simpler and safer than shared memory because there is no risk of overwriting shared data, but it incurs more overhead due to kernel involvement. Right, discussing some introduction to process synchronization. So it is a mechanism in OS which is used to manage the execution of multiple processes that access shared resources. Its main purpose is to ensure data consistency, prevent race conditions, and avoid deadlocks in a multi-process environment. On the basis of synchronization, processes are categorized as one of the following two types. First is either independent process, that is, execution of one process does not affect the execution of other processes, and second is cooperative process, where a process that can affect or be affected by other processes executing in the system. Now, it is the coordination of multiple cooperating processes in a system to ensure controlled access of shared resources, thereby preventing race conditions and other synchronization problems. Right. Now, roles of synchronization in inter-process communication. So we prevent race conditions using this. So processes won't be able to access or don't access shared data at the same time, avoiding inconsistent results due to synchronization. Then mutual exclusion allows only one process in the critical section at a time. Process coordination lets processes wait for specific conditions, and deadlock prevention avoids circular waits and indefinite blocking by using proper resource handling. Also, safe communication and fairness. Now, types of process synchronization. First is competitive. That is, two or more processes are said to be in a competitive synchronization if and only if they compete for the accessibility of a shared resource. Lack of proper synchronization among competing processes may lead to either inconsistency or data loss. And secondly, cooperative. Two or more processes are said to be in a cooperative synchronization if and only if they get affected by each other. That is, execution of one process affects the other process. Lack of proper synchronization among cooperating processes may lead to a deadlock. Right. Now, conditions that require proper synchronization, a critical section. It is a code segment that can be accessed by only one process at a time. It contains shared variables that need to be synchronized to maintain the consistency of data variables. So the critical section problem means designing a way for cooperative processes to access shared resources without creating data inconsistencies. Second is race condition, where it is a situation where that may occur inside a critical section. This happens when the result of multiple process or thread execution inside the critical section differs according to the order in which the threads execute. And then preemption is when the operating system stops a running process to give the CPU to another process, which allows the system to make sure that important tasks get enough CPU time. Issues arise when a process has not finished its job on shared resource and gets preempted. The other process might end up reading an inconsistent value if process synchronization is not done.